Welcome to section 7 of chapter Matrices. In the last section, we studied what is transpose of matrix and properties of transpose of matrix. In this section, we are going to study about symmetric matrix and skew symmetric matrix. Okay, so symmetry. A matrix A equal to Aij is said to be symmetric if A transpose equal to A. A matrix A equal to Aij is said to be symmetric if A transpose equal to A. That means A should be a square matrix. What about its elements? A transpose equal to A means Aij should be equal to Aji for all possible values of I and j. Okay. Now, for example, suppose I am forming a 3 by 3 symmetric matrix. So, A11. Suppose I am writing 2 here. A12 equal to 3. Aij equal to Aji. So, A12 should be A21. This element should be 3. Suppose I am writing 5 here. This element is A13, right? A13 should be equal to A31. A31 should be 5. Diagonal elements can be any. I'll write 7, A22 as 7, A33 as 10. Diagonal elements we can write any elements. Now, this position is A23, right? Suppose I am writing A23 as 8. Then A32 should be 8. So, this one is A32, 8. This is example for a symmetric matrix. You can just verify. This is A. Find A transpose. A transpose means transpose of this matrix. You have to interchange rows and columns. So first row changes to first column. Second row changes to second column. And third row changes to third column. So this is equal to A itself. So A transpose equal to A. Then we can say that a square matrix is symmetric. Now, next one is skew symmetry. Skew symmetry. A square matrix A is said to be skew symmetric if A transpose equal to minus A. A transpose. A square matrix A equal to Aij is said to be skew symmetric if A transpose equal to minus A. So what about relation between elements? Here it was Aij equal to Aji. In this case, it should be Aij equal to minus Aji. Aij equal to minus Aji. Now when I equal to j, we will get diagonal elements. Here you can write any diagonal elements, no problem. So but in this case, if I equal to j, what will get? I equal to j. Left hand side will be Aii. What about right hand side? Minus Aii. Because we are taking I equal to j. Aii equal to minus Aii. This element you can take to left hand side. So you will get 2Aii equal to 0. 2Aii equal to 0 implies Aii equal to 0. What is the meaning of Aii 0? A11 equal to 0, A22 0, A33 0. So, important point in case of skew symmetric matrix is diagonal elements should be 0. This is the proof. So, for example, A equal to, I am forming a 3 by 3 skew symmetric matrix. So, first diagonal element should be 0. Then only we will get a skew symmetric matrix. Suppose the element is 3, Aij should be equal to minus Aji. So this will be minus 3. A137, so A31 should be minus 7. Suppose A23 equal to 5, then A32 will be minus 5. So if we take transpose of this matrix, what will you get? If you take transpose, A transpose will be equal to first row changes to first column, second row changes to second column, and third row changes to third column. Is it equal to A? or minus A? This is clearly minus A because this one is A. So minus A means 0, minus 3, minus 7. Here we are getting minus 3, minus 7. So this is equal to minus A. So if A transpose is equal to minus A, we can say that matrix is skew symmetric. And if A transpose is equal to A, we can say that matrix is symmetric. Now you have to study some theorem from this section. So theorem 1. Theorem 1. If A is a square matrix, then A plus A transpose is symmetric. If A is a square matrix, then A plus A transpose is symmetric. We want to show that A plus A transpose is symmetric. So let C equal to A plus A transpose. So right hand side is a matrix. So C should be a matrix. So now we want to show that C is symmetric. How we will show that C is symmetric? Find C transpose. And you have to show that C transpose equal to C itself. So C transpose will be equal to A plus A transpose whole transpose. Now you have to use the property of transpose. What is A plus B whole transpose? A plus B whole transpose equal to A transpose plus B transpose. So this will be equal to A transpose plus A transpose whole transpose. This is again another property of transpose. A transpose whole transpose equal to A. So we'll get A transpose plus A. A transpose plus A we can write as A plus A transpose. Now what is A plus A transpose? A plus A transpose equal to C itself. So we are getting C transpose equal to C. That means C is symmetric matrix. This is theorem 1. If A is a square matrix, then A plus A transpose will be always a symmetric matrix. Now theorem number 2. For a square matrix A, A minus A transpose is skew symmetric. This is second theorem. For a square matrix A minus A transpose will be always skew symmetric. A plus A transpose symmetric and A minus A transpose skew symmetric. This one we can prove like this. Let C equal to A minus A transpose. So A minus A transpose is a matrix. So C is a matrix. Now we want to show that C is skew symmetric. That means we want to show that C transpose equal to minus C. So find C transpose. C transpose equal to A minus A transpose whole transpose. Now here you have to use the property of transpose. A minus B whole transpose equal to A transpose minus B transpose. Therefore this will be A transpose minus A transpose whole transpose will get. That is equal to A transpose. A transpose whole transpose is A. You will get A transpose minus A. That is minus of A minus A transpose. A minus A transpose equal to C. So this will be equal to minus C. That means we are getting C transpose equal to minus C. Therefore C is skew symmetric. So these two are two important theorems. For a square matrix A plus A transpose will be always symmetric and A minus A transpose will be always skew symmetric. Okay. Now theorem 3. Any square matrix can be expressed. Any square matrix can be expressed as sum of a symmetric and a skew symmetric. skew symmetric matrix. Any square matrix can be expressed as sum of a symmetric and a skew symmetric matrix. It's one result, also a theorem. Using this result, we can expect a question also. Any square matrix can be expressed as sum of a symmetric and a skew symmetric matrix. So consider square matrix A. We want to express A as sum of a symmetric and a skew symmetric. For that, we have to use result 1, theorem 1 and theorem 2. What is theorem 1? A plus A transpose is always symmetric. Theorem 2, A minus A transpose always skew symmetric. So we have to express A in terms of A plus A transpose and A minus A transpose. How we can express? Is A equal to A plus A transpose plus A minus A transpose? Is these two are equal? These two are not equal, because if we add these two, what you will get? A transpose minus A transpose get cancelled, but right hand side will get 2A, left hand side is only A. So in order to make this one equal, you have to multiply it 1 by 2. We know that A plus A transpose is symmetric. So 1 by 2 into A plus A transpose is, again, it will be a symmetric matrix. 1 by 2 into symmetric matrix will be a symmetric matrix. Same way, we know that A minus A transpose is skew symmetric. So 1 by 2 into a skew symmetric matrix will be a skew symmetric matrix. So now these two are equal, because if we expand right hand side, half into A transpose get cancelled with half into minus A transpose. Then half into A plus half into A, that is equal to A. In this way, we can express a matrix A as sum of a symmetric and a skew symmetric matrix. So first one is symmetric, this one is symmetric, plus this one is skew symmetric. So you can expect a question like this: express the given matrix as sum of a symmetric and a skew symmetric matrix. For that, you have to use this formula: A equal to half into A plus A transpose plus half into A minus A transpose, where half into A plus A transpose is symmetric and half into A minus A transpose is skew symmetric. Now we can do some questions based on this topic. So first question, let A equal to a matrix 5, 2, 1, 1, 2, 3, 3, 4, 3. Question is, express A as sum of a symmetric and a skew symmetric matrix. We want to express A as sum of a symmetric and a skew symmetric matrix. For that, you have to use the formula A equal to half into A plus A transpose plus half into A minus A transpose. We know that half into A plus A transpose is symmetric and half into A minus A transpose is skew symmetric. So first we have to find A plus A transpose. So our A is 5, 2, 1, 1, 2, 3, 3, 4, 3 plus A transpose, means transpose of this matrix. So first row changes to first column, second row changes to second column, and third row changes to third column. Now we have to add. So when we add, we will get 10. You have to add corresponding elements. 3, 4, then 3, 4, 7 you will get, then 4, 7, 6 will be. Is it a symmetric matrix? It is symmetric because A12 equal to A21, A13, A31, A23, A32. Diagonal elements can be any. So we want to find half into A plus A transpose. That is half into matrix 10, 3, 4, 3, 4, 7, 4, 7, 6. That is equal to, you can multiply with half, you get 5, 3 by 2, 2, 3 by 2, 2, 7 by 2, then 2, 7 by 2, 3. That is our first, that is symmetric matrix. Now you have to find skew symmetric. For that, first you have to find A minus A transpose. A equal to, a question, 5, 2, 1, 1, 2, 3 and 3, 4, 3 minus transpose of that matrix. So it will be 5, 2, 1. First row changes first column. Second column will be 1, 2, 3 and third column you will get 3, 4, 3. Right. Now you have to subtract. So we will get 0, 1, minus 2. Then minus 1, 0, minus 1. 3 minus 4 minus 1. 3 minus 1, 2 will get. 4 minus 3, 1. 3 minus 3 equal to 0. Is it a skew symmetric matrix? It is skew symmetric. Now you have to find half into A plus A transpose. That means half of this matrix. So you can write directly equal to 0, 1 by 2 minus 1, minus 1 by 2, 0, minus 1 by 2, 1, 1 by 2, 0. So we got our symmetric matrix, skew symmetric matrix. Now we want to express our question in terms of symmetric and skew symmetric matrix. That one you can write like this. So left hand side is 5, 2, 1, 1, 2, 3, 3, 4, 3. Then equal to symmetric. Symmetrics 5, 3 by 2, 2, 3 by 2, 2, 7 by 2, then 2, 7 by 2, 3, plus skew symmetric, this matrix, 0, 1 by 2, minus 1, minus 1 by 2, 0, minus 1 by 2, then 1, 1 by 2, 0. So we expressed square matrix A as sum of a symmetric and a skew symmetric. Here you have to stop. So this type of question you can expect for board exam for 2 mark or 4 mark. Now consider second question. If the matrix 6 minus x square 2x minus 15 0 is symmetric, find the value of x. It's a 2 mark question. So you can take this matrix as A. Let A equal to matrix 6 minus x square 2x minus 15 10. Given that matrix is symmetric, that means A transpose equal to A. A transpose. A transpose means 6 minus x square 2x minus 15 10. This is equal to A. A. This 6 minus x square 2x minus 15 10. Now how we can find the value? We can just equate corresponding terms. So we'll get 2x minus 15 is equal to minus x square. That means x square plus 2x minus 15 equal to 0. We want to find two numbers, product equal to minus 15, sum equal to 2 numbers are 5 and 3, plus 5 and minus 3. So we can write factorize this one as x plus 5 into x minus 3 equals 0. So we'll get value of x as minus 5 and value of x equal to 3. So we'll get two values for x. One value is minus 5, other one is 3. Okay. Now consider next question. If the matrix A equal to 0, A minus 3, 2, 0 minus 1, B 1, 0 is a skew symmetric matrix. So find the value of A and B. So skew symmetry means A transpose equal to minus A. That equation you have to use. A transpose equal to minus A. So A transpose means 0 A minus 3, 2 0 minus 1 and B 1 0 will get equal to minus A. Minus of that matrix. So that matrix will be 0 minus A 3 will get minus 2 0 1 minus B minus 1 0. Now you have to equate these two. You have to equate corresponding elements. So 2 equal to minus A. Minus A 2 means value of A will be minus 2. Now value of b, what is value of b? b equal to 3. You can use any equation, a equal to minus 2, same thing you will get. Minus 3 equal to minus b, b equal to 3. So value of a equal to minus 2, b equal to 3. Now next question, if a and b are symmetric matrices, then you have to show that AB minus BA is skew symmetric. If A and B are symmetric, then AB minus BA is skew symmetric. A and B are symmetric means A transpose equal to A and B transpose equal to B. That result you have to use for solving this question. So let C equal to AB minus BA. So since AB minus BA is a matrix, C will be a matrix. Now we want to show that C is skew symmetric. That means you have to find C transpose and you have to show that C transpose equal to minus C. What is C transpose? C transpose will be AB minus BA whole transpose will get. Now you have to use property of transpose. A minus B whole transpose equal to A transpose minus B transpose. So you will get AB transpose minus BA transpose. Right? Now what is AB whole transpose? That is B transpose into A transpose. So this will be B transpose into A transpose minus this term will be A transpose into B transpose. Now given that A and B are symmetric matrices, so B transpose we can write as B, A transpose equal to A, BA minus AB will get. Now what is C? AB minus BA. So we can take minus outside from these two terms. We get minus of AB minus BA. That is minus C. So C transpose we are getting as minus C. That means C is skew symmetric. Okay. Now we can do one more question. Express A equal to 1, 2, 4, 1 as sum of a symmetric and a skew symmetric matrix. This question you already did, but these type of questions are very important. That is why I am doing it once again. So you have to express A as sum of a symmetric and a skew symmetric matrix. So this formula you have to use. A equal to half plus half into A plus A transpose plus half into A minus A transpose. So first we can find A plus A transpose. A means 1, 2, 4, 1 plus its transpose you have to add, that is 1, 2, 4, 1. This will be equal to 2, 6, right? 6, 2. Is it a symmetric matrix? It is symmetric because A12 equal to A21. Now half into A plus A transpose should be equal to 1, 3, 3, 1. So we got a symmetric matrix. Now we want to find skew symmetric. That is half into A minus A transpose. So first we'll find A minus A transpose. That is equal to A 1, 2, 4, 1 minus A transpose. A transpose will be first row changes to first column, second row changes to second column. So if we subtract, we will get 0. Diagonal elements are becoming 0. 2 minus 4, that is minus 2. 4 minus 2, 2, 0. This is clearly a skew symmetric matrix. So half into A minus A transpose is equal to matrix 0, minus 1, 1, 0. Now you have to express our question as sum of a symmetric and a skew symmetric matrix. That is our last step. So answer is 1, 2, 4, 1. This is equal to sum of a symmetric. Symmetric is 1, 3, 3, 1 plus skew symmetric 0, minus 1, 1, 0. Here you have to stop because question is express matrix as sum of a symmetric and a skew symmetric. We need not add. So we can just verify 1 plus 0, 0, 3 minus 1, 2, 3 plus 1, 4, and 1 plus 0, 1. So we can conclude today's session. Next session I will come with another topic. Thank you.